Alright guys, so today we're going to start off with a lesson called Nomenclature of Alkanes. And if you remember from Chemistry 1, nomenclature is all about naming. And so what we're going to do is kind of for each group or type, like organic molecules, we'll talk a little bit about how to name them, and then we'll kind of proceed into diving into some of the reactions that they participate in, and then some of the real life, applications. For example, where can we see these things in the real world? And so our learning targets today are to, 1, describe the rules for naming alkanes, and 2, correctly apply the rules to then, go on and name any alkane molecule that you're given. And again, these are some great resources that I've kind of collected from masterorganicchemistry.com and also chemistry steps as well. And so first of all, kind of what's in a name. So in chemistry, it's really important that we have a consistent system for referring to organic chemical compounds. And that system is called the IUPAC system. That's IUPAC. And that stands for the International Union of Pure and Applied Chemistry. And so within a name, there's kind of 4 different parts, that we need to be familiar with. For most of us, as individuals, we may have kind of 3 parts to our name: a first name, a middle name, a last name. Some of us may have 4 names, just kind of depending, on different things. But for our molecules, we're going to look at 4 different parts. So first of all is the suffix, which this would kind of be like our, last name. And so the suffix, that comes at the end of a name, and it's used to denote how long the main chain is, all right? If you're not dealing with a big long chain of carbons, then the suffix is rather instead used to identify the main or highest priority functional group. Like if that functional group is an aldehyde or a carboxylic acid or an amine, something like that. Okay, and so if we look at this kind of example name here, it's really long, but at the end there in yellow, we have highlighted the word nonane. That non stands for 9, and so highlighted in our molecule, kind of the main chain is 9 carbons long, all right? And so that is the suffix. It's at the end of the name, and it tells us the length of the main chain. So there's our suffix, and it tells us our main chain is 9 carbons long. All right, the second part of the name is what's called the substituents, okay? The substituents are just any groups that are attached to the main chain. And so what I've done on my molecule here is I've kind of highlighted those substituents in blue, those different groups that are attached to the main chain. Now the way each substituent is named kind of reflects how many carbons are present. And so what we'll get to in a second is there's kind of a name associated with different numbers of carbons. So like 1, we associate kind of the prefix meth, 2, eth, 3, prop, 4, but. And so those groups, they tend to take that kind of prefix, that meth, and add a YL. So that's where you see things like methyl, ethyl, propyl, so on and so forth, okay? Now, third, we have prefixes, and those are used to tell you how many of a group are present. So, for example, if we look at these 2 groups kind of down here, we have 2 methyl groups. Methyl groups have 1 carbon each, and we have 2 of them, so we use the prefix di. These will be the same prefixes that we used in covalent nomenclature, like mono, di, tri, tetra, so on and so forth. And then finally, the last part of a name are what are called locants, or sometimes locators. And they are numbers that tell you which carbon a group is located upon. And so, for example, if we look at the first part of this name that says 3-ethyl, what that does is that tells me there is an ethyl group on carbon 2 within the main chain. On carbon 3 within the main chain. So if I start kind of with my carbons, I've got them already numbered. And if I look on carbon number 3, I see an ethyl group there that has 2 carbons. Okay. If I go to the 4th carbon, I should see 2 methyl groups there because that 4 is repeating. And I do see that as well. Then on carbon 5, I have kind of a branching group that's called 1-methylpropyl. And we'll kind of talk about branching groups here in a second. But those are your basic parts of your name: the suffix, substituents, prefixes, and locants. And that kind of helps us piece the molecule together. So what we're going to do is work through kind of the general rules to naming, do a few practice problems along the way, and then let you have some time to practice on your own. So the first rule when kind of building your name is to find the longest linear chain or the largest ring of the molecule. And so what we're essentially doing first is we're going to establish the suffix, and try to find how long is the main chain, okay? And so if you happen to have a tie between how long, the chain can be, the main chain is going to be the one that contains or is attached to the most substituents or smaller groups. And then also, if you're kind of faced with a ring versus a chain, if they're the same number of carbons long, the ring will take priority over the chain. So let's just kind of practice here, for a second. So when we've got our molecule, like this first one, let's pretend that we're trying to find the longest pathway we can build. So we might go 1, 2, 3, 4, 5, 6, 7, 8. So going this direction, I counted 8 carbons. Let's see if I go here. 1, 2, 3, 4, 5. So this is kind of a 5 carbon long pathway. And then if I go from all the way kind of down, 1, 2, 3, 4, 5, 6, 7, 8, 9. This pathway gives me 9 carbons. And so I want the one that gives me the longest chain, so this will be the chain that I choose, all right? And so the name for a chain that's 9 carbons long is non-ane. And they'll all end in ane because these are all alkanes at the moment. And so you may be wondering, okay, well, why did they put the first carbon, down here at the bottom and call the 9th carbon the one here at the top? So what we'll find is that the way you number the main chain, it should be numbered so that the lowest number carbon is closest to the first group or substituent. So for example, if we kind of trace out that line again for the 9 carbons. So here are our 2 substituents. And so if we start from this carbon, the first substituent is 1, 2, 3 carbons away. But if we start from this carbon, the first substituent is 1, 2, 3, 4 carbons away. So that's what makes this carbon the better choice for the first one, is because we'll arrive at a substituent sooner. All right, so there we go. So that main chain for us would be non-ane. Now let's go ahead and try it on the next one. So here, again, you're looking for your longest chain. So if we go this way, 1, 2, 3, 4, 5, 6, 7. However, if we take a turn, 1, 2, 3, 4, 5, 6, 7, 8, that gets us our longest chain. The name for a chain with 8 carbons is octane. Okay. And again, the reason that this carbon is the first carbon is because numbering it that way has less distance between the first carbon and the next substituent or smaller group. All right, now we have a ring and a chain. And so what we need to do is kind of count the path length on each and decide if they're longer, if one is longer. If it is, we'll choose the longer one as the main chain. But if they are both the same length, then the ring will take priority. So if we count with the ring, it's 1, 2, 3, 4 carbons that we have. If we count with the chain is 1, 2, 3, 4 carbons long as well. Since both of them have the same number of carbons, this is where we follow the rings take priority rule. And so if we go down to kind of our bottom corner here, a ring with 4 carbons is called cyclobutane. So but is kind of the organic prefix for 4. And if it's a ring, we put a cyclo in front of it. So this will be called as the main part, cyclobutane. All right. So now that we've practiced kind of naming our basic parent chain or main chain, let's go ahead and practice kind of filling in the substituents or the groups. So again, like we talked about, you number your carbons so that your first carbon is closest to the next substituent. Then what we'll do is when we're trying to decide what the substituents are, we want to classify them according to the length of the carbon chain. So for example, this substituent has 1 carbon. Substituents with 1 carbon kind of go with the prefix meth, and you add the ending YL. So this group with 1 carbon is called methyl. This substituent with 2 carbons is called ethyl. 3 carbons within a substituent is propyl. 4 would be butyl. 5 pentyl. 6 hexyl. Kind of so on and so forth. All right. And so when we're kind of naming the substituents, we want to point out which carbon that they're on. So the ethyl is on the 3rd carbon, so we would say 3-ethyl. The methyl is on the 5th carbon, so we would say 5-methyl. Then our parent chain is 8 carbons long, so the suffix would be octane. So 3-ethyl, 5-methyl, octane. All right. So now what we're going to do is kind of apply the same principle to the second example. Here we have a propyl group on carbon 4. So we'll say 4-propyl. Then our parent chain is 7 carbons long. So if we go over, we can look for 7. 7 is called heptane. So this will be 5-propyl heptane. All right. And so to kind of point out for you, if you'll put a kind of star or a mental note by these kind of groups at the bottom, sometimes you have groups that are a little more complicated than just like your methyl, ethyl, propyl substituents. They can take on kind of different patterns, like your isopropyl, which kind of looks like kind of the inside of a peace sign maybe. There's sec-butyl, which is kind of 4 carbons attached to a stick, if you will. There's isobutyl, there's tert-butyl, tert-pentyl. And so it says these names are trivial, but actually kind of in the real world, they're probably a little more, commonly used than the more formal, IUPAC names. And so you'll kind of get used to these as we go along, but just know that they're here kind of for reference as we continue working. All right. So we're through our first 2 guidelines. Let's knock out the next one. So this one we actually kind of already worked in. And so it says number your chain starting from the end that gives you the lowest possible locants for the substituents. Now, if you happen to have a tie, then the lowest locant rule is alphabetization. Whew, that's a hard word to say. It's basically where you're putting things in alphabetical order. And so if the molecule, on the other hand, is just a ring with only 1 group, there's no need to provide a number because no matter the way you turn the ring, that substituent will still be on the first, carbon. All right, so let's take a look at these right here. So for this first one, we kind of have 7 carbons in the main chain, and we're trying to figure out, should we number it starting with 1 on the left and 7 on the right, or should we do it with 1 on the right and 7 on the left? Okay. And so if you notice, in both cases, they put a methyl group on kind of the second carbon. Then, in the first case on the left, then you have your next substituent on carbon 3, and then you have your final substituent on carbon 6. So you have a substituent on 2, 3, and 6. On this other example, you have a substituent on 2, 5, and 6. Okay? And so what we're going for is we want the lowest possible locants. So 2, 3, and 6 are lower than 2, 5, and 6. Okay, so that means we would choose this system of numbering for those particular carbons. And so what we have is we have 3 different methyl groups. So we'll list their numbers. They're on carbon 2, carbon 3, and carbon 6. Then, because there are 3 of those groups, we'll include the prefix tri. So this is trimethyl. It's methyl because they all have 1 carbon. Then you include the parent name for 7 carbons, which is heptane. All right, so we would go with the first option there, 2, 3, 6, trimethyl heptane. All right, so now let's look at another option right quick. So on these, again, kind of same molecule, and we're having the numbering debate, which way should we number the chain? So what happens is in both cases, they end up putting a substituent on carbon 3 and carbon 5. So we can't really go based off the lowest number. So instead, what we have to rely on is alphabetization. So what we'll do is we'll kind of name the substituents. This substituent on carbon 3 has 2 carbons. This is an ethyl group. And the second one is a methyl group. So we'll kind of put that there. Ethyl versus methyl. All right. And so what we're going to do is kind of number the chain according to alphabetical order. And so ethyl, since it starts with an E, it's earlier in alphabetical order than methyl that starts with an M. So we're going to choose the option that gives ethyl the lowest number of 3, since alphabetically it comes before methyl. So our name for this one will be 3-ethyl, 5-methyl, and it's still heptane because you have 7 carbons at the end. All right, then finally we have a ring, and this is just kind of illustrating that last point there, that if you have a ring with a substituent, there's no need to provide a number. And so here, this is a methyl group, so saying methyl cyclohexane is the same thing as saying 1-methyl cyclohexane. And so technically, there's no need to provide that 1 there. Okay, so that's just a point, if you have only 1 group sticking off of a ring. All right, so now let's go on. We're getting close, guys. Let's see, 6 guidelines, so halfway there. Okay, so 4th guideline, if there are multiple instances of the same substituent, then we'll use the prefixes di, tri, tetra, etc. Okay, and it's important that we use some sort of number locator for all of the substituents. So for example, if you have 2 methyl groups on the second carbon, you'll need to list that number 2 twice, once for each of the groups. Okay, so let's look at this first one. So we have a methyl group with 1 carbon attached to both carbons 3 and 5. All right. And so what we're going to do in this case is account, for both of those methyl groups. So we'll say 3, 5, all right. Then we have 2 of those methyls, so it's dimethyl. Our chain is 7 carbons long, so our suffix will be heptane. So this is 3,5-dimethyl-heptane, all right. So now let's look at the next one. Here we have 2 methyl groups attached to the 4th carbon. And so it's pointing out that we'll need to list the 4 twice to account for both methyl groups. So it's 4,4-dimethyl-heptane. And it's showing kind of a few common mistakes here. So one is not listing the 4 twice. And the second common mistake is listing the 4s twice, but then forgetting to say dimethyl. And that's just showing that both of those 4 substituents are methyl groups. Dimethyl means 2 methyls. They just both happen to be on the same carbon. All right. So now let's go on to guideline 5. Okay. And so this one says for branched substituents, number and name them separately from the main chain. And it says these names are going to be placed in parentheses. And so by branch substituents, we're talking about substituents that kind of have other groups coming off of them. So like, for example, on this one, if you notice how it has like an ethyl and a methyl group kind of protruding from its main connection to the main chain. And so these branch substituents are also where the more kind of commonly used names of isopropyl, isobutyl, tert-butyl will kind of come into play as well. Okay. And so we've got kind of this little box kind of to diagram this for us over here. And so it says treat each branch substituent as its own naming problem. And so it says carbon 1 of the branch substituent will be where it meets the main chain. So for example, the carbon 1 is kind of the first carbon that's connected to the main chain. All right, so here's our main chain here, kind of outlined in gold for us. And so what we're going to do is then kind of on that carbon, we're going to look for the longest chain. In this case, the longest chain of that attached carbon is 3 carbons long. And so that corresponds with the name propyl, all right? Then off of that kind of chain, you have 2 methyl groups that are attached to carbon 1. And so the name for this entire group becomes 1,1-dimethyl-propyl. So propyl is being treated as the main chain, with the 2 methyl groups being accounted as being attached to that first carbon in the propyl chain. All right, let's take a look at this other one down here. So for this other one, the longest kind of chain connected to that attached first carbon is 2 carbons long, which makes it ethyl. Then to that, you have 1 methyl group attached on carbon 1. So this will be called 1-methyl-ethyl. So you have 1 methyl group attached to the first carbon of that ethyl substituent. Okay. And so if we go and kind of put this all together, what we have is we also have kind of a simple substituent on the 3rd carbon. That's a methyl. Let's not forget about him. So the whole IUPAC name will be 3-methyl. And then on the 4th carbon, we have kind of this odd, branched chain, the 1-methyl-ethyl, which we named just a second ago. And that will go in parentheses. So on the 4th carbon is the 1-methyl-ethyl. All right. Then on the 5th carbon, we have another branch chain. So we're going to put a 5 and open up our parentheses. The 5th carbon was our 1,1-dimethylpropyl. And then in case you thought we were finished, even though our paper's running out, we still need to add on the main chain name. Since our main chain was 9 carbons long, the final suffix will be nonane. Okay. Now, that was kind of a lot. And so this is kind of where the more common names come into play in helping us with those more difficult, branch substituents. And so what happens is these groups, kind of these branch substituents here, actually have more common names. And so this one, again, it kind of looks like the inside of a peace sign. This is actually called an isopropyl group. So kind of scroll back up and let you see that. So here's your isopropyl group. Then if we kind of look for what matches the other one, that would be the tert-pentyl group. And so what that means is you have a tertiary carbon at the center, and pentyl is referring to kind of 5 carbons that you have as well. So tertiary carbon at the center, and you have a total of 5 carbons there in that branching group. And so this guy, this other chain, this is called tert-pentyl. And sometimes instead of them saying tert for tertiary, they'll just leave it as a T, and it'll say T-pentyl. So again, that's a tertiary carbon with 3 other carbons attached, and then you have a total of 5 carbons. And so if we were to name this using the common name, we will say for isopropyl 3-methyl, and then 5 tert-pentyl nonane. All right. And if you'll notice, you may be wondering, well, why did the order, swap? What we're doing is we're kind of naming the order alphabetically. So I before M before the TP there. Or before the P. And that's because we're about to find out that the tert is excluded kind of when you're alphabetizing. All right, so hang in there, last rule. And again, this just takes a lot of practice, kind of a lot of determination to get this down. All right, rule 6, here we go. So it says, assemble the final name by arranging the substituents in alphabetical order. And so the di, tri, tetra, those prefixes are excluded, which means we don't use them when we're alphabetizing. Also in, tert, I, and sec. And so don't ask me why. They decided to exclude those, but they did. So just kind of have to get used to that. Now, even though isopropyl and isobutyl start with an I, they're going to be alphabetized just normally as you would anything else. So let's look at this one right quick, the 1, 2, 3, 4, 5, 6, 7. So here, what we have is we have 1 methyl substituent on the 3rd carbon. So we would say 3-methyl. Then our parent chain is 7 carbons long, so that becomes heptane. All right. Then next we have a ring. It's 4 carbons long, which is longer than either of the chains, so the ring is going to take priority. So that will kind of be our suffix, the cyclobutane. Butane is for 4. Then we have an ethyl group on carbon 1, and we have a methyl group on carbon 2. And so we may be asking, okay, does it go ethyl-methyl or methyl-ethyl? So here, we're going to put ethyl first because alphabetically it comes before methyl. And that's also why it is given the first carbon. So this will be 1 ethyl, 2-methyl cyclobutane. So 1-ethyl, 2-methyl cyclobutane. Again, ethyl comes first, and it gets the first carbon due to being before N or methyl in alphabetical order. Then finally, for the rousing last example here, we have a big chain that is 9 carbons long. And so we know that nonane is going to be our kind of final ending there. Nonane. Now let's go back and kind of name our substituents. So here on carbon 3, we have a substituent with 2 carbons, so this will be an ethyl group. On carbon 4, we have 2 methyl groups, so we'll have to remember to say dimethyl. Then on carbon number 5, this is going to be a branched substituent. So if we kind of count it, that longest chain is 1, 2, 3 carbons long. So that'll be a propyl, and it has 1 methyl group attached. So this will be 1-methylpropyl. Or if we wanted to use the more common name for it, we could go and look back at our examples and see that this would be called sec-butyl. That's this little guy right there. Okay, so let's name this last one then. So alphabetically, ethyl again comes before methyl. So we'll start off with 3-ethyl, and then there are 2 methyls, so 4,4-dimethyl. And then on the 5th carbon, we have that branched substituent. I have to rotate my paper here. So on the 5th carbon, then we open our parentheses, we have 1-methylpropyl. All right, and then finally, there's that ending nonane. All right, so that's a big long name. Aren't you glad, you're not that molecule having to go to kindergarten and learn to spell your name for the first time? Definitely take a lot of practice, but I'm sure you could get it down. All right. So what I would recommend is kind of before you continue on, kind of definitely stop the video, kind of take time to go back, look over the guidelines that we've kind of just gone through, try to digest them a little bit more. And I'll also post kind of an Alkane Nomenclature summary sheet that kind of, walks through this with a little bit more examples, kind of one more time. And then what I'm going to do is kind of within the video, I'm going to pull up a few practice problems, let you kind of pause the video, work them, and check yourself. And then there will be a few more practice problems for you to kind of try out on your own in Google Classroom. So I'm going to swap over to my practice problems kind of right quick. And so the first ones I'd kind of like you to try is highlighting and naming only the parent chain in each of the following compounds. And so I'm going to have you just right quick do A, B, and C. So it says highlight and name only the parent chain in each of the following compounds. So pause the video right quick, try A, B, and C, and then we will check your answers. All right, so welcome back. Let's go down and check those answers right quick. So answers for A, B, and C. The longest chain on A was 7 carbons long. So we'll call that heptane. The longest chain on B was 6 carbons long. And that 6 carbon chain kind of beat out the 5 carbon ring. So we'll call that hexane. And then finally, kind of have to be careful on C, but the longest chain was 9 carbons long, which is nonane. All right. And so with that little exercise, I'm actually going to go ahead and release you to go and try some of the practice problems on your own. But as always, good luck, and let me know if I can be of help. And hang in there, this takes just lots of practice, but you'll get it.